Are going to be exploring this amazing physics topic known as sound. Well, a lot of people might understand sound in a lot of different ways. You might know that you can hear things. You are very familiar with the fact that sound travels and that's why we can hear it. But I want to present a different idea to this today. Well, we're just going to touch upon the notion that sound is a perception of motion. Wait, what? I can see when something's moving from here to there. It's very easy for me to see. What kind of motion is sound? Well, today's session is going to be broken down into 4 sections on what is sound, musical instruments, and we're going to see some basic instruments like string instruments, percussion instruments, so on and so forth. And we're going to explore how sound propagates. Now, propagation of sound is basically movement, all right? Now, what is propagation? We'll explore. And what is moving when sound happens? We'll explore that. And then, of course, we have human hearing. How are you able to hear me? Maybe through your speakers, maybe through your earphones, so on and so forth. But what exactly is happening when you're hearing something? Well, that's what today's session's all about. Let's explore with what sound is. First up, let's jam. Okay, hold on. See what's happening here, right? You know that you're listening to something called music, right? Now, what exactly is music? Music is just a collection of sounds that sounds pleasant to us. That sounds like you can differentiate different things that are there. As you can see here, we had drums. We had, you know what, I'm going to go back a little. Okay. You could hear drums, you could hear some plates or metals clanging sounds, you could hear the guitar. Now, all of these individual things that produce sound are called sources of sound, or we call them musical instruments. Let's take a closer look at each of those, right? We have those string instruments, and we have these dub, 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 and we call them percussion instruments. Take a quick closer look at each of these. Right, you see, string instrument on top, guitar. At the bottom, we have the drum. Now, forget what kind of guitar it is and what kind of drum it is. Let's try to listen to each of these. Oh, look at that. There seems to be something moving there as well. You see the strings? Of course, this is in slow motion. This is just a fake sound that I've added in here for us to empathize with it. Now, what's happening at the bottom? Okay. What about... Whoa! That was nice in slow motion, wasn't it? Interesting. So I have string instruments where the string seems to be plucked and it's doing something. I have a percussion instrument where the percussion sheet seems to be hit and that's doing something. Now, what exactly is this something that's happening? There's movement, you see? That movement is what is perceived by us as sound. Quick closer look at something known as a tuning fork. Have you come across a tuning fork ever maybe in your laboratories in school or whatever else? It's a thin slice of metal, right? Now that metal happens to produce a sound when it's struck. You know what? Let's just listen to that. I'm going to turn that off. That is the sound that's produced by a tuning fork, and every time you strike a particular tuning fork, it produces the same sound. Or at least it sounds the same whenever we strike it, right? Now, you see there, we show that there's something happening here. There's a to and fro motion that these guys are doing. That to and fro motion is known as vibration of an object. Right? And detecting that vibratory motion is what our ears do, and we perceive the world around us as sound thanks to that. Now, okay, cool. So what exactly is this vibration thing? Now, vibration, as you might have heard or you might have learned earlier, in motion, we have something called oscillatory motion. Have you heard of this term, oscillatory motion? When you studied motion in time and all of those, you might have come across this fancy little guy called a pendulum, right? Now, a pendulum is basically a weight which is hanging down, and then you give it motion, and it does that kind of a motion where it keeps doing this again and again and again. Now, it's really hard for us to visualize that in a string unless we make it really slow motion like I've shown you in that animation there, or that video clip there. This is easier for us to observe in the form of a pendulum's motion, right? Now, I said sound is a way that we perceive movement and oscillatory motion, and this pendulum is also moving. So every moving pendulum, will I hear it? I mean, my hand is doing oscillatory motion, but I can't hear anything about my hand. Now, how does this translate to sound? First up, let's appreciate that this to and fro motion is what is vibration, all right? And sometimes vibrations are very easy to observe, like in the case of a pendulum, but like in the case of the string, it's not that easy to observe. In fact, when you play sounds from a speaker, this is kind of what's happening on the speaker as well. Not the big motion, but there's some very minute motion that's happening there as well. And if I drop some paper pieces in there, I can actually see them fluttering about. Why? Because that motion is hitting the paper pieces and causing it to move as well. It's very similar to how a pendulum works. It's not exactly the same, but it's very similar to how a pendulum works. The reason we cannot hear a pendulum is because our ears are designed to read a particular kind of vibratory motion that's not necessarily visible to the naked eyes as sound, right? So sound essentially is vibratory motion that's perceived by some sensory organs in our body, specifically the ears. Now, this sound is made amazing use of in different cultures in different parts of the world through what we call musical instruments. Do you play any instrument? Do you play the guitar? Do you play the flute? Do you play the piano? Well, speaking of playing the piano, we had this person here, Ludwig van Beethoven. He played some amazing melodies. In fact, a lot of his tunes are today used in elevator doors and so many other places. Now, the fun part about why I wanted to say this is you need not have the capacity to hear to produce amazing music. This man was actually completely deaf. By the age of 35, 45, he was completely deaf, and yet he was composing amazing music. So we see that sound can be produced, sound can be received and perceived by us, and we don't really need that perception of sound to produce or create music. Turns out that our body experiences these oscillatory motions or sound in more than one ways. We can also feel music, and which is how Beethoven was able to create it. In fact, you should go and do internet searches on DJs, DJs who are deaf. And you'll find that around the world there are many DJs who purely rely on how they touch and feel the vibrations to create awesome music. Speaking of music, I'm sure you've encountered a guitar. The other thing there is called a bango, which is a native instrument of certain countries. Now, these guys work on the principle of a string that is stretched out. Think of it like a rubber band. Now, I have a rubber band in my hand. You hear that tuck, 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 tuck? There's something fun that happens when a string instrument is playing, all right? Let me show you that in a little more detail with a slow-mo of something that you might have been familiar with already. You see those individual strings there? When you strum each of those strings, and I've made this in slow motion, mind you. If you try looking at a guitar, you might be able to observe it, but it's so fast that it's happening that you might need a slow motion camera to capture it in that much of detailing. You see, each of these guys is moving to and fro and to and fro, to and fro and to and fro. And there's something that seems to be flowing along them. That flowing motion is known as a wave. And that movement of the wave is known as, I think I already introduced this to you, propagation. All right? Now, this string instrument as such uses the fact that the string propagates waves, and then something happens and air lets us listen to it. We'll see what that is in a little while. Another kind of instrument that produces sound is something that we call a percussion instrument, something that you hit to listen to sound. In fact, here I have with me a xylophone. Have you ever played with a xylophone? You hit the metal pieces, you can hear sounds. I actually want to do some little playing for you. You hear that, right? Now here's some fun things that I would like you to observe. So here up, I have, so I'm holding it closer because mic is there, right? So you can hear this. What if I hit it harder? How do you think the sound would change? It'll get louder, right? You have that instinctually. That's ringing in my ears. And each of these metal pieces has different sizes and different lengths and different thicknesses as well. And each one produces a different sound. Wait, what did I do? I just whistled, right? Is whistling a form of percussion? Well, I'm not hitting anything. We'll see what whistling is in just a little while. For now, let's explore what happens when I hit a plate, which is also called a cymbal or music instrument, in slow motion. You see that amazing movement that's happening there? Yes, it might not be as visible when somebody is just playing the cymbals, but on slow motion, you can actually see that there's that wave propagation, just like in the strings, happening even on that plate. That back and forth motion is what happens to generate sound.